Hai, Assalamualaikum warahmatullahi wabarakatuh. My name is Nabilah Huda, Binti Muhammad Yussuf from Mathematics 2, and I'm going to present on applying learning theories in teaching and learning mathematics in subject curriculum studies and learning theories in primary school mathematics. So, for introduction, teaching mathematics effectively requires a deep understanding of how students learn, and two influential learning theories, Bruner's learning theory and Ausubel's learning theory, provide valuable insights for educators. Bruner emphasizes the importance of discovery learning, where students build mathematical concepts through active exploration and progressively structured. This presentation will explore how teachers can apply these theories in the mathematics classroom to enhance students' comprehension, engagement, and problem-solving skills. Bruner's learning theory. Jeremy Bruner was an American psychologist who made important contributions to cognitive psychology and education psychology. According to Bruner, the education should aim at creating an autonomous learning environment with learners essentially learning how to learn. It applies equally to children and adult learners alike. Through his research on children's cognitive development, Bruner proposed three modes of representation, which form a part of his learning theory. So what are these modes of representation that Bruner referred to? When we talk about modes of representation, we refer to the way human beings store and encode information in memory. Bruner believed that all learning occurs through these modes of representation. It is therefore important that these modes of representation are used to actually design a curriculum. Because all learning is based around these modes of representation, we come to a concept called the spiral curriculum. Bruner believed that any subject of any difficulty can be taught to a child at any stage of development. This is in contrast to Piaget stages, which advocate that curriculum should be designed in accordance with the stage of development of a child. Bruner stated that any subject can be taught at any stage with gradual increase in difficulty. Bruner also uses scaffolding, which means students learn by themselves but need guidance and support from adults as well. Teachers aid the existing knowledge of students, demonstrate the process of learning, and then supervise and guide the students as the learning process continues. Now let's look at these actual modes. Inactive mode. This mode is based around actions and reactions. The word inactive has the word act in it, referring to these being action-based learning. In this mode, a person will understand objects by performing actions on them and observing the reaction that come out of it. This mood is dominant in the ages of 0 to 1 in an infant's life. An example of the inactive mood would be if an infant wants to understand a circular object like a ball, for instance, it would actually touch and feel the object and its curvature and can even put the object in its mouth. And that would be the inactive mood in play. The next mood is the iconic mood. This mode is based upon visual summarization of objects. In other words, we can link our experience with objects to picture or visualizations. The ability to store a mental picture of an object in the mind comes into play here. This tends to be the dominant mood for children between the ages 1 to 6. Continuing on the example from above, the child who needed to feel a circular object can now draw an image of a circular object, a ball for instance, or think of the image of a ball. The next mood is symbolic mood. This mood is more flexible than the previous two moods and is the last to develop. In this mood, information is stored in the form of a code or a symbol, like a language. Symbol and codes can be stored, classified, and manipulated. Continuing on with the same example, the child can use the image of the ball visualized previously and use it as a part of a language by calling the object a ball or as a part of a mathematical equation as well. Let's presume calculating its diameter or its radius. Storing information about an object symbolically can imply storing the objects in language form, in mathematical equations, in musical forms, or in any other form. Spiral curriculum. It means that students revisit the same topic at regular intervals, with the complexity increasing each time they revisit it, ensuring that each learning step is linked to the previous stage and merely continues on. Because of the repetitive nature of this style of learning with increasing difficulty, this style of curriculum is called a spiral curriculum, and this is a very important concept in Bruner's theory. Bruner was a strong advocate of designing spiral curriculums. After learning about Bruner's theory, we realized that Bruner used both cognitive and constructivist approaches. The key difference between constructivism and cognitivism is that constructivism explains that learners use prior knowledge to understand new knowledge, while cognitivism explains that learning takes place through the internal processing of information. Moreover, although the learner is an active participant in the construction of knowledge in both constructivism and cognitivism, the teacher or the instructor plays different roles in these two learning theories. The instructor facilitates an active learning environment with a constructive approach, whereas the instructor creates an environment where thinking activities and processes take place in cognitivism. Furthermore, strategies like interactive group activities are used in constructive theory, while sorting activities and note-taking activities are more used in cognitivism. Also, in constructive theory, learners use their previous knowledge to understand, whereas in cognitivism, the learner's mind always tries to make connections with external factors and internal knowledge. In addition, there are different principles in constructivism, but there are no specific principles for cognitivism. Bruner's learning theories, which include cognitive structure learning theory and discovery learning theory, can be applied in mathematics teaching to enable students to comprehensively master the knowledge structure of mathematics. Discovery of learning theory is an activity in which students organize what they know in their own way rather than books. This method emphasizes students acquiring knowledge independently through reading and thinking. Teachers should provide materials that encourage students to analyze, synthesize, and discover rules, thus becoming discoverers. One example is, teacher asks students how to calculate the area of a circle. Students exploit by hands-on operation, and teachers can remind students in this process that the circle can be turned into the geometry that they have learned, so as to find the area of a circle. Cognitive structure learning theory. This involves connecting similar concepts and organizing them into meaningful structure, which means learning is about arranging and rearranging cognitive structure. Teachers should assist students in establishing connections between new and old knowledge to create a comprehensive knowledge system. From the diagram, when students learn the knowledge of square, they do not grasp the concept and nature of square in isolation. Instead, link the knowledge of orthomorphism to other geometric knowledge, such as quadrilaterals, parallelogram, rectangle, diamond, and rhombus. The goal is to guide students to shift from passively accepting knowledge to actively discovering and independently inquiring, thus making learning a personal and independent activity. Bruner stated that no matter what the subject we choose to teach, we must make sure that students understand or master the basic structure of the subject. Implication of Bruner's learning theories in teaching mathematics. Bruner's learning theory has direct implication for teaching practices. Involvement in using prior experiences. It encourages students to use their prior experience and structures to learn new knowledge. Categorization of new information helps students categorize new information to see similarities and differences between items. And last but not least, scaffolding knowledge assists learners in building their knowledge, gradually reducing this assistance as it becomes unnecessary. Bruner's learning theory emphasizes adapting tasks to students' developmental characteristics and maximizing individual potential. Teachers should consider students' original cognitive levels when assigning tasks. Instruction must be appropriate to the level of the learners, which means being aware of learners' learning moods, inactive, iconic, and symbolic. It will help you plan and prepare appropriate materials according to the difficulty that matches the learner's level. Providing feedback that fosters intrinsic motivation. Grades and competition are not as helpful in the learning process. Bruner states that learners must experience success failure not as reward and punishment, but as information. Ausubel's meaningful learning theory. Ausubel's learning theory emphasizes meaningful learning through deductive reasoning, contrasting it with rote memorization. Meaningful learning is when new knowledge is acquired by relating it to existing knowledge structures. Meaningful learning is crucial for transferring information to long-term memory. Ausubel advocates using advanced organizers to link new material with existing ideas, particularly when the material is difficult or complex. Advanced organizers can be comparative and expository. Phase 1. Introduce an advanced organizer to clarify the aim of the lesson and relate new information to the student's prior knowledge. Phase 2. Present material using examples and engage students in meaningful learning activities. Phase 3. Strengthen cognitive organization by relating the organizer to students' prior knowledge and presenting materials in terms of basic similarities and differences. Application of Ausubel's meaningful learning theories in mathematics activities. Before teaching a new topic, teachers can use advanced organizers to help students relate new information to what they already know. Before introducing types of quadrilaterals, the teacher can show pictures of real-world objects such as windows, tiles, books, kites, and ask students what shapes they notice. This helps activate prior knowledge of rectangles and squares before discussing properties of parallelograms, rhombuses, and trapezoids. Building on prior knowledge for better understanding. Teachers should ensure students understand simpler concepts before progressing to a complex one. When teaching symmetry, the teacher can start with basic shapes such as triangles, square, circle, and ask students to fold paper cutouts along a line to see if both halves match. Once students grasp line symmetry, they can extend their understanding to rotational symmetry using a pinwheel or a fidget spinner. Implication of Ausubel's meaningful learning theory in teaching mathematics. When teachers use advanced organizers such as real-world objects to introduce geometric concepts, students can better connect new information to their existing knowledge. This leads to improved conceptual understanding, greater engagement, and better retention. When teachers ensure that students understand basic concepts before introducing to a complex one, it results in smoother learning progression, reduced cognitive overload, and stronger problem-solving skills. Next, we move on to implication of Ausubel's meaningful learning theory based on individual differences. The first one is differentiated instruction. Since students come with varying levels of prior knowledge and learning abilities, Teachers must adapt their teaching strategies to meet individual needs. For visual learners, teachers can use diagrams, charts, and real-world images to introduce new geometric concepts. For verbal learners, teachers might use detailed explanations and discussions before moving into problem-solving activities. Personalized pacing and scaffolding. Not all students learn at the same pace, so some may require some more time to integrate new information with existing knowledge. In a lesson of symmetry, some students may grasp line symmetry quickly, while others need additional practice with hands-on folding activities before moving on to rotational symmetry. Okay, we have arrived to the conclusion. By integrating Bruner's and Ausubel's learning theories into mathematics instruction, teachers can create a more effective and engaging learning environment. Bruner's approach encourages students to actively explore mathematical concepts, while Ausubel's emphasizes on meaningful learning ensures that new knowledge is connected to prior understanding for a long-term memory. When applied thoughtfully, these theories enable educators to support diverse learners, ultimately leading to a stronger foundation in mathematics. Thank you for listening to my presentation. Assalamualaikum warahmatullahi wabarakatuh.